lecture 12. In this video, I will talk about function composition, which basically means some difference product and quotient of functions. And then later, I will talk about composition of functions. Now, what do we mean when we say sum, difference, product, and quotient? Just like numbers, we can perform these mathematical operations onto functions. That's what we mean by this, basically. So, for example, if we have two functions, f and g, let me just write them. I can add these two functions, and the notation for this one, or this is basically means f plus g of x. Now you may wonder, what does this mean? What do I mean when I write it this way? What does it mean? Well, basically this means here we have the individual functions f and g, and we're adding them up. And here what we have is, first you add the two functions and you evaluate at x. For example, when we evaluate, or if we want to evaluate the sum of these two functions, basically what it means is when you evaluate the sum of the two functions, after you add them at x, that's the same with evaluating the two individual functions at x and then sum them up. Okay, that will give you the same result. And similarly for f minus g of x, this is f minus g of x is equals to f of x minus g of x. F times g, this dot is times f times g of x is f of x times g of x, and f over g, or f divided by g of x, is f of x divided by g of x. Well, since this is division, we want this denominator to be different from 0. Therefore, we have to have this restriction. So we write this g of x different from 0. We want this to be different from 0. And the domain of this combination, or this summation or difference or product or division, is the intersection of the two functions. Okay, the intersection of the domain of the two functions. And for example, but for this one, we have a restriction, which means here we add this restriction because we have to omit the values that make this g of x equals to 0. Okay, now let's look at this example. Let's say we have f of x equals to absolute value of x, and g of x is 2. Now, f plus g of x is basically means f of x plus g of x. Now, what is f of x? Well, f of x is this. So I have it here. And g of x is a constant function. So we have it here. Therefore, f plus g of x is the sum of f of x and g of x. Therefore, it's absolute value of x plus 2. And now if we look graphically, if we look at these three functions, g of x equals to 2 is this red line, and f of x equals to absolute value of x means the blue line, and the composition, or f plus g of x, is this black line. Okay, now if you see, this is a shift. This is a shift of this absolute value, or as you can see, the blue line is shifted upwards by 2 units because of this one. Okay. Now, for example, if we are asked to evaluate f plus g of x at, let's say, x equals to 1. Okay, so here already we have the function, so we can, of course, evaluate it here. f plus g of x, I have this function, which is absolute value of x plus 2. Therefore, f plus g of x of 1 is absolute value of 1 plus 2, which is 3, because this is 1, positive 1. But from the formula, we know f plus g of x is f of x plus g of x. Now, what is f of x? Well, f of x is absolute value of x, so it's absolute value of 1, right? And what is g of x? Well, g of x is a constant function, so it doesn't change. Whatever x I choose, for whatever x or for any x, the value of the g of x, it doesn't change. It's 2 because it's a constant function. Therefore, this is 2. Even though we pick 1, well, it's constant. Therefore, we have again 3. So as you can see, in the second, like here, what I did is I evaluated the individual functions, f separately, which is this one, at x equals to 1, and g of x at x equals 2. Therefore, for g of x, this is the output. For f of x, this is the output. And then the sum is 3. And then here, what we did is we have the function f plus g of x. We got it from here because already we found it. And we evaluated this function, f plus g of x, at x equals 2. Therefore, using these two ways, we get the same result, which confirms this equality, okay? And it's the same for the remaining or for the others. And regarding the domain, so here we have f plus g of x. For f of x, which equals to absolute value of x, the domain is, well, this is the blue line. So either you can use the graph to figure out what values of x, what value of x it takes, or you can just look at this one. Just ask yourself, is there any value of x that makes this one undefined? Okay. Well, this is absolute value function, and it can take any value of x. Negative, positive fraction, it doesn't matter. 0, it doesn't matter. So domain for this function is negative infinity to positive infinity. And as you can see from this graph, the blue line, it's going horizontally. You look at the horizontal side. So this arrow is going horizontally. It's going to the right, right? Of course, it's going up and horizontal both because it is diagonal, right? So looking at the x values, it's increasing to the right. And similarly, this blue on the left side, it's going to the left as well, right? So the domain is from negative infinity to positive infinity. And for g of x, it's this red line. Well, obviously, this is going to positive infinity and negative infinity. And again, here, it's the same. And what's the intersection for this one? For f plus g of x, we said the domain is the intersection. And the intersection of these two is basically the same set. Okay. Or you can look at this graph, and it has basically the same behavior as this blue line. Now, let's consider these three functions, and we will try to evaluate the composition or the combination of these functions. So we have f of x equals to negative 2x and g of x by this function or this statement, and h of x is 1 over x minus 3. So for part A, we are asked to find g plus h of 0. And we know g plus h of x is g of x plus h of x. Therefore, g plus h of 0, just replace this x by 0. So we have this one. Okay, so this is what we have here. Now for g of x, this is g of x. Evaluate this function at x equals to 0. Replace every x by 0. So we have 0 plus 4 in absolute value, which is 4. Okay, this is from g of 0, and from h of 0, this is h of 0. So if we replace this x by 0, we have 1 over -3, which means -1 over 3. So we have -1 over 3. And if we subtract this, we get, well, multiply this by 3 over 3, we have 12 over 3 minus 1 over 3, 11 over 3. Okay, so this is the output, or the g plus h of 0, g plus h of x evaluated at x equals to 0. And for the second part, we have f over g of 8. Well, we need to evaluate f of g at x equals to 8. And again, by definition, this is the same with f of 8, or f evaluated at 8 divided by g evaluated at 8. F evaluated at 8 is f of 8 is -2 times 8, which is -16. And g of 8 is 8 plus 4, which is 12. Okay, so if we substitute these values in here, we get -16 over 12. Simplifying this, we get -4 over 3. Okay, therefore, this is how we evaluate combination of functions. Okay, it's not that difficult, just we need to be careful on this. And another thing, when we are asked, or if we want to figure out or determine the domain of this combination of functions, we have to figure out the domain of the individual functions, and then we can take the intersection. Or what we can do is we can find the combination. For example, we can find g plus h of x as a function, not evaluated, but as a function, by adding the two functions. And then we can find the domain of that function, that new function. Okay, that's another way. All right. Now, another thing is when we have functions like this, and now here we will see how to find the domain, okay, for the combination of two functions. So let's consider these two functions now. P of x equals to x squared plus 3x, and q of x equals to square root of 1 minus x. Now we are asked to evaluate this given function. Well, these are the given functions, and find the domains. And we need to write the domain in interval notation. Now here we have p times q of x. Okay, p times q of x. So by definition, p times q of x is just p of x times q of x. Okay, here we have p of x times q of x. Now what is p of x? Well, p of x is x squared plus 3x, and q of x is square root of 1 minus x. Okay, so here I have the new function, which is given by p times q of x, right? So now what is the domain of this function, this new function? Well, let me write it here so that we can see it clearly. This function, we got it to be x squared plus 3x square root of 1 minus x. Now, looking at this part, we don't have any problem because this is always a real number. It doesn't matter what value you choose for x, the output for this expression is always a real number. Okay, I only care whether the output is real or not. Okay, if I put, or if I choose an input, okay, if the output is a real number, then I can use that input as a domain, or I can put it in the domain, right? But if the output is not a real number, then the value that I choose for x should be excluded. Therefore, for the first part, we don't have any problem for this, okay? But this one, well, we do. For example, if the inside part is negative, what happens? Let's say the 1 minus x is, let's say, -3. What happens? This is root 3, root -1. This is root 3i. And we remember this is an imaginary number. Therefore, what we are trying to do here is we are trying to avoid such things. Okay? Which means we don't want this inside to be negative number. Therefore, we want 1 minus x to be greater or equal to 0. Okay? As a whole, this is the part that is in the square root, right? So we want this part, which is inside the square root, to be greater or equal to 0 always. And in order to satisfy this condition, what would be the value of x? That's the question now. Now we solve this one. This is an inequality. So we solve this. And if we solve this, if I move this, if we add, if we subtract 1 from both sides, what do we get? We get -x greater or equal to -1. If we multiply both sides by negative, x less or equal to +1. Okay, because we flip this one. Therefore, here, in order this guy to be greater or equal to 0, x has to be always less or equal to 1. Otherwise, for example, if I pick a number greater than 1, let's say 2, 1 minus 2 is negative. Therefore, the number inside the square root is becoming negative. So now what is my domain, or what is the domain of this function? We know this, we found this one. And this part, it doesn't have any restriction. Therefore, this is the only problem, right? Therefore, to write this one in interval notation, here we have 1, 0, and here we have the negative numbers. Okay, so we are saying this is the domain all the way to the left. Now, how do we write this one in interval notation? Well, this is basically -infinity to 1. Now here, is it included? The 1? Well, it's included because here we have equal sign. Therefore, I put this one square bracket. Okay, and here is the domain. And similarly for this one, p over q of x. P is, well, this is given by definition, p of x over q of x. P of x is x squared plus 3x, and q of x is square root of 1 minus x. Now, there is a bit different from the previous one now. There is a slight difference, and we have to be careful on that. Okay. So here we have p over q x equals to x squared plus 3x over square root of 1 minus x. Again, the top part, the numerator, we don't have any problem with it now because it always results in a real number. So again, the problem with this one, there are two things with the denominator now. One is it is inside a square root. Another thing is it is a denominator, it's on the denominator side. So what's the problem with denominator? Well, we don't want any denominator to be 0. Therefore, one thing, we want the inside part, or the inside the part inside the square root to be greater than 1, and from the first question, we know that in order this to be greater than 1, x has to be less or equal to 1, right? This is just from the square root. And another thing is, we want 1 minus x, or square root of 1 minus x, to be different from 0. Okay, the whole thing on the denominator, we want it to be different from 0. So in order this to be different from 0, well, this inside has to be different from 0. This is the same way as 1 minus x different from 0, and then x has to be different from 1. Okay, the number that makes this 0 is when x is 1, right? So if x is 1, the whole thing on the denominator will be 0, and all this function will be undefined. That's why we are putting this restriction. Therefore, what we do is we remove this equality. Okay, this equality, because here we have the restriction, so we remove this equality, and then here this one, we put this, the remaining, they are the same. Therefore, the domain becomes negative infinity 1 instead of this square bracket. Now you see the importance of this square bracket and curly bracket, the parentheses, not curly. Here I will use parentheses, which means this parenthesis, the 1 is not included, but in the previous one, the 1 is included. Here excluded and here included. Okay. So this is how we find the domain of this combination of two functions. And the next is difference of quotient. Quotient, difference of quotient is, first let's start with this average rate of change. Last time we learned how to find slope of a line, and in application, which this is one of the very important, well, not only this one, but both of this, in particular this difference quotient. So it's important, particularly in calculus, if you are planning, or if you are going to take calculus, then you will see this one again. So here, let's say we have a function, this blue line, let's call it f, and pick two values of x. Let's call them x1 and x2. Now, when you evaluate f of x at x equals to x1 at this value, then the point is this one. So this point is x1 comma f of x1. F of x1 is always the y value, okay? This y value. And the x value is x1. And the second point is f evaluated at x equals to x2. So the x coordinate is x2, and the y coordinate is f of x2. So the point is given by x2 comma f of x2. Now, as you can see, this is not a straight line, it's a curve, right? Now, we have this so-called average rate of change. This is usually in business to find average rate of change, or in physics, or even in mathematics, when we drive this slope, and a lot of other applications, it's very useful. So to find this average rate of change of this one, we find the slope of this second line. This second line is the line that connects these 2 points. So the slope of the second line is the y value, f of x2 minus f of x1 over x2 minus x1. Basically, this is the slope of this second line, okay? Now, keeping this in mind, let's use now a little bit different notations. Now, instead of x1, let's call this one x here in the next graph. And instead of x2, I will call this distance to be h. So if this is x, then this is x plus h, okay? if this distance is h, then this point is x plus h. So that's what we have here. So we have x value as x and as x plus h, and then the points will be x comma f of x and x plus h, which is this corresponding value, this x value, and the y value at this point is f of x plus h, which means f evaluated at x equals to x plus h. Now applying this formula, we get f of x plus h, the y value, minus f of x over x plus h minus x. Now this x and x, this is x positive, this is negative, so they cancel each other. Therefore, we have this number, okay? And as you can see, this h is this distance, the difference between these 2 points, okay? So this is what we call the difference quotient, okay? This is what we call the difference quotient. Now, let's see how we can find difference quotient for this given function. Now, let's say we have f of x equals to negative 4x squared minus 2x plus 6. So just to simplify this one, and not to make it too complicated, I will find it step by step. So first, let's find f of x plus h. And we will try to simplify it as far as we can. So f of x plus h basically means evaluate this function at x plus h. So I will replace every x in here by x plus h, and we will simplify that. So this is negative 4x plus h instead of x squared minus 2 times x plus h plus 6. And this is negative 4. If we square this one, we get x squared minus plus 2xh plus h squared minus 2x minus 2h plus 6. Again, simplifying this, I will distribute this to each of them. So we have negative 4x squared minus 8xh minus 4h squared minus 2x minus 2h plus 6. As you can see, we don't have any things to cancel out here to simplify. And then we have, well, f of x is already here, so I don't need to write that one. So I will f of x plus h minus f of x now. We have this, and we subtract this from whatever we found here. So this is negative 4x squared minus 8xh minus 4x squared plus 6. I'm not going to write this one again, so I will just distribute this one first. So this will be plus 4x squared plus 2x minus 6. And then we have this remaining part here. Okay, just write it down here. And let me change. So let's see, and let's see if we can find anything to cancel out. So we have this positive and negative, so they cancel each other. We have this one, they cancel each other, and we have this constant, they're gone. So this difference is negative 8xh minus 4h squared minus to h. And further, this I can factor out, well, we can factor out h from here, so that minus 8h x, sorry, minus 4h minus 2. All right, and the next step becomes finding the difference quotient divided by h. Well, now we found the numerator, it's just this one. Over h, so this cancel out, therefore it is this. Sorry, this is not there, yeah. So this is the quotient, the difference quotient, okay? So this is how we find the difference quotient. Basically, it's just evaluating f at x plus h and then subtracting f of x from this, whatever value result we have here, and then divided by h, and that will give you the difference quotient. And the next topic is composition of functions. Now, composition of functions, let's consider two machines. And here we have input, let's call it x. So we put this x in machine G. I will call the first machine G. So when you use x as an input, and then it will be processed here, and the output will be G of x. Okay, so the machine G is taking x and it's outputting G of x. This is the y value. Okay, and then take this as input to machine F. We take this as an input to machine F, and machine F will take this G of x as an input. It will process it, and it will take out, or it will give us f of G of x as an output. So G of x is an output of this and an input of this one, which means it's a domain to this, and it is a range inside the range of G of x. Okay, so this is what we call the composition of function. So coming back to the formal definition, the composition of f and g denoted by f of g of x, f of g, f o g. So there is difference between this f o g and we have earlier this one. So this is product and this is the composition. So this o means of. Okay, so f of g is defined by f of g of x, which is f of g of x. Now, when we say f of g of x, we have f evaluated at x equals to g of x. We know how to evaluate this, for example, right? For any function, f, we know how to evaluate it at x equals to 2, for example, okay? Now, instead of evaluating f at a given number, we evaluate f at a given function g. And that's basically what's happening here. So the domain of f of g is the set of real numbers x in the domain of g, such that g of x is the domain of f. And we will see how to find that one here. Okay. So it's easier to see it using an example. So we have, for example, we have this functions m given by this and q given by this function. And we are asked to find g of m of x. So gm of f of x, sorry, not g, q of m of x is q of m of x. Now, q of m of x means evaluate this q at x equals to m. Okay, and we have our q 1 over, now instead of x, I will replace this one by m of x minus 10. And my m of x is square root of x plus 8 minus 10. Okay, therefore, this is the composition of q and m. Now, how do we find the domain of this one? We need to find the domain of this function. Okay, this is our new function. Now, the technique is the same again. First, we see if we need to put any restriction. And of course, we do have, because we have a square root. And whenever you have a square root, if you see a square root in a function, you have to put a restriction, because we always want the value inside the square root to be positive. Therefore, we want x plus 8 to be greater or equal to 0, which means x has to be greater or equal to -8. Okay, so from this restriction, we got, or from this criteria, we got this restriction. X has to be always greater or equal to -8 just because of this restriction. Another restriction is from the denominator. This is from the square root. And from the denominator, we want the denominator to be different from 0. Whatever, every denominator has to be different from 0. Okay, and in this case, we want x plus 8 minus 10 to be different from 0. Okay, now to solve this, to find the value of x which makes this one 0, we just ignore this inequality or this not equals to sign and replace it by equal sign. Let's find what value of x makes this whole value equals to 0. So I will replace this by equals to 0. Therefore, we have root x plus 8 equals 10. I will move this one to the other side. And using the square raising to the same value of this index, because this is square, both sides, we get x plus 8 equals to 100. And then moving this one to the other side, we get x equals to 100 minus 8, which is, 92. Okay. Now, here we said this has to be different from 0, right? And the value that makes this equals to 0 is 92. When x is 92 here, 92 plus 8 is 100. Square root of 100 is 10. 10 minus 10 is 0. So this is the value that makes this one 0. And we don't want this to be 0. Therefore, in order this one not to be 0, x has to be different from 0. Okay, this is what we are looking for. Therefore, we have two restrictions here. So let's put those 2 points, those 2 numbers. Let's say this is -8. I have 0 here. Let's say we have 92 here, and it's going to the right and to the left. Now, using this first restriction, it says x is greater or equal to -8. So starting from here, it's included. We go to the right. Now, when I reach here, we have this, and it says x has to be different from -2, -92. So I will put this, which means we are excluding this guy, and we continue again to the right. Okay, we don't stop here, we continue. We just skip this point. Okay, therefore, we have 2 intervals. This interval is from -8 to 92. This is square because this is included, but this is parenthesis because 92 is excluded. Union. Again, we have another interval here And that one is starting at 92, exclusive, 92 is not included again, up to positive infinity. Okay, so this is the domain of the new function, the composition of Q and M. Okay, so this is how we find the domain. All right, so this will be the end of this section, as well as the end of this chapter, and hopefully you get the concepts. Well, if you have any questions, always feel free to email me and to ask at any time. All right, so see you in the next lecture with chapter 3. We will start, of course, chapter 3. All right, see you.